So here we take decision tree as the underlying algorithm for all the samples which you have chosen from the original data. Then what we do is we try to create an ensemble classifier, which is basically a collection of the outputs from individual classifiers on each of the samples. So basically, as you know, decision trees are the ones which have been pretty important from a perspective of capturing rules in the database in the data. And one problem is we typically have a problem of overfitting. But in this random forest, what we do is we divide the sample into multiple samples and run decision trees on each of them. Each of these samples are random, and we can say they are disjoint in the sense they are not they are collectively probably handling representing the original sample, and now each of them is run independently a decision tree. And then when you look at the class prediction from random forest perspective, basically you try to see that for individual tree what is the conditional class, what is the probability of it being classified based on the tree, and then you combine the probabilities obtained from each tree. That is what gives you the random forest output when you have a new input that is coming in. So see here, it's basically if the random forest was totally not random, it was one big sample, it would have been one decision tree. But here you're taking that and putting several disjointed samples, running decision trees on them, and then taking the sum of the potential classification. So random forest is very interesting in the sense that it has a very powerful averaging effect, and historically it has been shown as one of the very powerful techniques in machine learning as compared to pure decision trees. So a lot of inventions happened in decision trees, but it's only recent past that random forests have really taken on a big might, and in fact some cases they're doing better than neural nets also. So